See this, we have to prove that the value of this determinant is 2abc into a plus b plus c whole cube. It is given in some pattern, right? So we have to make the transformations in such a way that we finally get this expression. There are various ways to express it, but then we have to make the corresponding changes in such a way that we get this. Okay. So first of all, I would like to make most of the elements as zeros if possible. Otherwise, most of the elements as some value, numerical values like 1. So if you observe it, these two values are same, and these two values are same, and these two values are same. So by applying some column transformations, it is clear that we can make one of them as zeros, right? So just to make that this one as 0, I'll take column 3 and I subtract it from column 1, then I definitely get 0 here, right? And again, in order to make this one as 0, I'll take column 3 and I subtract it from column 2, then I'll get this as 0, right? So I did that. So I did these two transformations, then we got this. So here and here we got it, right? And now after doing this, even I have expanded this, like this. So we get b plus c square minus a square. When I apply c1 minus c3, I get b plus c minus c square minus a square. It is in the form of a square minus b square, which can be written as a plus b into a minus b. Therefore, I expanded it out like this: b plus c plus a into b plus c minus a, right? And again, likewise, I expanded all of them. So I got these 4 terms. This one we didn't change anything here. Now if we observe it, in the resulting determinant here, the first column is having the term a plus b plus c here and here, which is common. So I can pull it out, right? And again, the second column is also having a plus b plus c here and here. I can pull it out. Anyway, the other one is 0. So if I take it out as common here, a plus b plus c, here a plus b plus c, then I get a plus b plus c whole square, and I am writing the remaining terms there. Got it? And the next one is, I'll try to see if I'll try to apply this transformation so that I can make most of the terms as zeros. So I am applying this transformation. R3, the row 3 is replaced with row 3 minus row 1 plus row 2. So add these two terms and then subtract it from here, right? Then after adding these two and subtracting it from here, I got these 3 factors. This one as the third row. So why did I do this? You'll understand it now. So after applying this row transformation, I got the factors like this. Now if you observe it, here there is 2b and here there is 2ab. I'll divide it with a, and here I'll get 2b, and I'll add these two and replace it here. Then I'll get 0 here. And here there is 2a and here there is 2ab. If I divide it with b and then add it with this, then I get 0 here and I replace it here, so that I'll get most of the factors as zeros. I am doing the same, which means I'll divide the third row once with a, add it with this, once with b, add it with this, and replace the corresponding results over here, column 1 and column 2. Then I got 0 here and 0 here. That is what my intention is. And now we know that if we expand this determinant across this column, this row, third row, then you need not worry about the cofactors of this, you have to worry about only the cofactor of this. And the index of this one is, this is third row, first column. Therefore cofactor is nothing but minor, isn't it? Because minus 1 power 1 plus 3 is nothing but 1. So I'm just taking this element here and writing it here, and then the minor of this element is, you have to remove this column and this row and take the remaining elements which I have taken here, right? And now you can normally find out the determinant as you do. So if I find out the determinant, I get b plus c into c plus a minus, when I multiply these two, I got this, which can be summarized like this, right? So we finally got the determinant as this value. See, there are various ways to solve it. I am showing you one of the ways. You can follow your own method. Maybe it will be interesting if you try to find out the determinants on your own and then later check with my answer and my procedure. Even if you follow some other procedures also, you'll end up getting the same expression, or sometimes what happens is you'll get an expression which is expanded form of this. You might not get directly this form, right? Anyway, when you see the expressions, they should be equal, final expressions. So I suggest that you do it on your own and then check with my solution. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.